Hi Calculus, we are on our Big FRQ for the graphs FRQ, and essentially this can be given two different ways. One is kind of like what I have here, where you're going to be given a graph and it just tells you, okay, this graph is the derivative of g, okay, or of f. Or they may say that, for example, g of x is equal to the integral from like 2 to x of f of t dt. And if that's where you start out with, the first thing I'd want you to do is to derive both sides, and note that if you are taking the derivative of the right side, you have second ftc, and you just get there. And so once again, we're back to where we started, where the given graph is the derivative of g. Okay, so there's a couple of different ways, and you'll see once we start working with actual past FRQs that they'll be given either way, okay, but essentially the same thing. So let's look at this. Let g be the function defined by g prime equals f, and let's assume the graph of f is given somewhere, okay, and let's also assume that they've given us this point that g of a, of little a, is capital A. So let's say we want to find g of b. So again, you're looking for one function value given a different function value. So let's use FTC rearranged. So g of b is equal to g of a plus the integral from a to b of g prime, which is also known as f of x. Okay? If you're given a graph, remember that there's two ways to find a definite integral. One is to antiderive, which we don't have an equation. The other way is to find area, okay? So let's make a little note for ourselves here. We're going to put area from x equals a to x equals b. I've got quotes because make sure you're subtracting the area below the x-axis. Okay, all right. The second part, part B, says find g prime of b or state that it does not exist. Well, g prime of b will be the same as f of b if I come back up here, right? And this will just be the function value, right? You're given the graph of f, so you're just finding what is the y value of the given graph when your x value is b. Part C says find the second derivative, g double prime, evaluated at b. So the second derivative evaluated at b for g will be the same as the first derivative of f. And if I'm finding that, remember to find that, you're given the graph of f, so this will be slope. And by the way, the slope does not exist if there's a corner. Let's do this. Reminder. Slope DNE at corners, right? So you may see that. We're having issues here. Okay, part D, for which values of x is g increasing and decreasing? Justify. Now remember, you're not given the graph of g, you're given the graph of f, which is the derivative of g. So g is increasing when g prime or f, either one, the given graph is positive. So in other words, above the x-axis. And conversely, g is decreasing when g prime, which is f, is negative. Think about your diagram. So that would be below the x-axis. All right, part E, find all values of x where g has a critical point, and then classify each critical point as a location of a local min, max, or neither. Justify. All right, what is a critical point for g? Critical point for g is where g prime is 0 or DNE. For these, I've never seen one where they throw a graph at you that has a DNE. And remember that f is the given graph is g prime. Okay, so once we have those, essentially once you've got the x-intercepts, then you can classify each one as a min, max, or neither of G. Okay, so again, think about your diagram. G has a relative max when its derivative, G prime, which we're calling F, changes from what to what? Changes from positive to negative. Because remember, that means that G will change from increasing to decreasing. That would create that kind of that peak, right? And conversely, G has a relative min when G prime does what? Changes the other way. So it changes from negative to positive. And if it has no sign change, like if it just touches and turns on the x-axis, that would be neither. Part F, for which values of x is G concave up, concave down, justify. So if I want to check the concavity of G, I would need to check what aspect of the given graph, G prime. We need to check the increasing, decreasing. So G is concave up when the given graph, G prime or F, is increasing. And conversely, G is concave down when the given graph, G prime, is decreasing. Part G, for which values of x does G have a point of inflection, justify. So point of inflection is where G, a point of inflection on G, is where G changes what? It's where G changes concavity, but you're not given the graph of G, you're given the graph of G prime, so again, think about your diagram. G will change concavity when G prime changes from increasing to decreasing or vice versa. So G has a point of inflection when G prime, which is F, changes from increasing to decreasing or vice versa. And I'm just going to make a little note here to read the graph carefully. Because what I see a lot is, you know how to find where something changes from increasing, decreasing, but what happens is that one becomes obvious, right? Because it's a corner. But a smooth piece right here oftentimes gets left out because students just go and look for the corners. So just read the graph carefully and just tell yourself, okay, increase, decrease, decrease, increase, so you really catch all the changes of direction. Part H, find the average rate of change of G from x equals A to x equals B. So remember, average rate of change on G, that's G of B minus G of A all over B minus A. And remember how we found G of B. If you need it, we did that in Part A. Part I, find the absolute min and max values of the graph of G on the closed interval A to B. Justify. Okay, so when we are finding absolute min and max values on a closed interval, that's where we make our table. Okay, we know we're going to need to put our endpoints on the left side of the table, and goodness, we also know we need to find our critical points. So critical points first. Critical points are where the derivative is 0 or undefined, right? And so let's say that you have two x-intercepts on the given graph. Let's call them C and D. Okay, now we're going to come make a table. X and G of x, because I'm trying to find the absolute min and max values on G of x. Okay, so always plug into the original. I need my endpoints, A and B, and any critical points, so we're going to assume we have two, so we're calling them C and D. Now for G of x, if you're not given a formula for G of x, we're going to come back to how we did Part A, okay? So remember, for here, I was trying to find B. So what I'm going to do is do the same thing I did in Part A, but instead of finding B, I want to find G, C and D as well. So if I want a formula, I can just replace anywhere I see a B, I'm going to replace it with an X or a T, whatever variable you want to use. And keep in mind that this piece was given, right? So here, that was G of little a needs to be given, capital A. Okay, so some point needs to be given. So let's come back here. G of X is going to be G of little a, whatever was given, plus the integral from a to whatever x value I'm looking for of G prime, which is also known as F. Making sure I'm using different variables here on the limits of integration versus the integrand. Okay, and then you're just going to plug in. So G of A is just going to be G of A, which was given to be capital A. And then for C, I will replace C here. And remember, to find that piece, let's make a note for ourselves once more. For this piece here, we go area under the curve. And then you're just going to pick your smallest value if they ask you for your min, your largest value if they ask you for your max.